So, monitoring and debugging with Minecraft. A little bit of a silly talk, bit of fun, and I think we all need a bit of fun at the moment. So that was the motivation behind the talk in the beginning, and got a bit carried away with Minecraft recently. I only just started playing, and this is sort of the output of all that, and I'd like to share. So who am I? My name's Jeremy. So yeah, work at a security company here in New Zealand. Got a background in electronics, embedded systems, all kinds of software. I've worked on all sorts of things now in security. Craziest hobby being public speaking. Never thought I would do that as I was younger. I was the person to make a speech about speeches. No, really. And a bit of a hardware hacker, software smelter. I do like the odd dad joke. And Minecraft. Well, you probably are quite familiar with Minecraft already. If not, it's a wonderful game. And I only recently started playing it, even though it's been around for a long time. And it's a lot of fun. Some stats. So, worth quite a lot of money, sells heaps of copies, famously $2.5 billion acquisition, sold 200 million copies. So I guess Microsoft was onto something. 100 billion total views of videos on YouTube. That's really crazy. It's a very great game to watch on YouTube because it's so creative, and also the licensing is quite great from Minecraft. They sort of say, "Hey, share our game on YouTube. We're happy." Well, I guess they get more sales, so it's not all altruistic, but and a 25% increase in players during the pandemic. So I was one of those, and still 126 million monthly active users. So a pretty massive game. And for me, currently in Minecraft, I've done almost 1,000 kilometers traveled around in the game. So it shows you how much time I've spent so far, or 80,000 spacebar jumps, 6,000 eggs thrown around. Yeah, it's fun to waste a bit of time. But then during lockdown, I started riding my bike around my area, and I wanted to convert the kilometers that I'd ridden into resources in Minecraft to sort of motivate me to ride a little bit more. And so I set up the system where I would track my ride and then count the kilometers and then give myself that many diamonds in Minecraft. So you can cheat and give yourself resources. I don't recommend doing that without some kind of effort put in, but I thought that maybe cycling was a good effort, and then I would get the reward of the diamonds, and I wouldn't have to go and mine them. And I set up an experiment with my friend. He was mining in the game, and I was out cycling as fast as I could. And we came back, and I had 23 diamonds, and he had 5. And now we have labeled a section of the world the Corridor of Despair, where he mined for hours, just getting only 5 diamonds. So it's a lot of fun. This is my first sort of thought of, hang on, I can kind of interact with this game a bit more than just through the game itself. How can I start hacking this game? Because really, hacking and Minecraft goes so well together. It is such a great match. There's so many things you can explore, and I was really just scratching the surface. I sort of had that question of, I wonder if I can automate giving myself these diamonds. How would I do that? And you start looking into it. You start watching a couple of YouTube videos. Your YouTube recommendations gets flooded with hundreds of different YouTube videos because they're like, YouTube's decided now that you like Minecraft, and then it's just this great world of all these different people doing all sorts of different projects. So, you might have come across a couple. I'm going to name a few here because they're so fascinating. Like implementing Pokemon inside Minecraft, and you can see a sort of a shot there of underneath this beautiful sort of world on top of where the game actually works, and you can play through the game. They've implemented it with all these command blocks and structure blocks. It's just insane. Thousands and thousands of hours gone into these kinds of things. Someone actually put Minecraft inside Minecraft. I don't actually know how this works still. There was also a video how they completed the game inside Minecraft. And that was most challenging because all the blocks they're seeing are like the blocks inside Minecraft, the different colors you can have, but the resolution's not so great. So he had a bit of trouble. Quite an amusing watch. Pack.png, a really fun project to look into because they're going into a little bit more about the procedural generation side of Minecraft and how they could reverse engineer the procedural generation to figure out where like a classic screenshot was taken. So there's this classic screenshot you can see there that no one really remembered what this seed of the world was, because these worlds are randomly generated. And so there was this project that was set up to find that world, and a really cool story, a really interesting history behind that. So that was really cool as well. You could even add some mods into Minecraft. So there's other ways to hack widgets. You can extend the functionality rather than kind of like building things inside Minecraft. Open Computers caught my eye, and it's you can program computers in Lua inside Minecraft, and you can sort of craft computer pieces. That was quite interesting. And even implementing a CPU in Minecraft. So I think this is with 100% in-game mechanics, implemented a processor, because you can start having sort of logic gates and things like that, where you use this component called redstone, where it will trigger certain things based on the inputs. Just amazing. So I can't do any of those. Really good projects to look into. But I did come across this video, and it was this world's smallest Minecraft server, and there it is on the right. And I thought, that's really interesting. And I've got a background in these embedded systems, and I thought, I wonder how they've done it. And they actually implemented the Minecraft server protocol in this microcontroller, and that was really cool. I thought, oh, that's what I want to do, and I'll have a look into that and see if I can do that myself. So I had on my desk at the time a impulsively crowd-purchased piece of electronics that I hadn't really done anything with beyond loading up the demo, which is BlitBoy. It's this little Bluetooth microcontroller that can run MicroPython, but it's a really cut-down version of it's not the whole Python, CPython you'd be used to. It's like a sort of kilobytes versus megabytes. But yeah, you can write your program in Python, which makes it quite accessible to program electronics, and also a lot faster. So that was what I was going for. I liked the less effort to reward ratio. I don't really mess around with my toolchain and compiling C programs and all that. I just wanted it to work. So I'll tell you a little bit about the Minecraft protocol. It's got this really great client-server model, even if you play single player. And it's just TCP bytes sent across the socket. Sometimes it's encrypted. If you have your account and you've bought the game and you sign up, then it's encrypted. But you can also play in a mode where it's just offline only and it's not encrypted. There's really great resources available that describe in depth what the protocol is. They change every so often, so you got to keep up with the protocol. So if you're looking at different projects, it'll often say, "Hey, this project works with this version of Minecraft." So you got to take that into consideration. If you find a project you really like, it could have been created a while ago and only work with an older version. So an example of the kinds of packets that is sent backwards and forwards in Minecraft. Well, you've got this hexadecimal, this binary packet format. It's all this binary format, and essentially the length of the packet, and then we've got 8 bytes following this one, and then we've got some kind of ID to tell us what type of packet it is, and then we've got some data following that. And so this login start is the first command, the first packet that gets sent when you want to join the server, and it's basically saying, "Here's my username, I want to start." And you can see the string here is even broken down. There's a little length for the string, and then JEREMY will be encoded in ASCII into that field. So they've got all sorts of different encodings for different kinds of information in this protocol. An interesting one I came across was the variable integer format. So they've got this way of packing data into different size bytes. So if you need small numbers, you can use 1 byte. So you can see I've got here 5, 16, and 63. Those numbers we represented in binary as 101, 1000, 11111. That's fine. But if you want a bigger number than that, what happens? Well, 128, it has this sort of the most significant bit of this byte is reserved to say, hey, there's another byte following this one. So then all these rest of these bits are representing the number, and then this most significant bit is saying, hey, no more bytes following this one, and then here's the final piece, and then this would be the most significant bits, and this would be the low significant. So it's kind of a bit interesting, right down to this byte level of how the data is encoded on this protocol. So just for example, this really massive number would be 4 bytes long. And this lets you send really small numbers quite efficiently, but then really big numbers, if you need to, you can take as many bytes as you need. And you're just sacrificing 1 bit every byte just to sort of have this variable width format. It is actually a standard format. It's an IEEE format, LEB 128. So I happened to find this Python implementation already done for me. And I just copied and pasted it into my code and gave it a reference. So in hexadecimal, that might look like that. And then the rest of the world, so there's all this procedural generated world goes out to almost infinitely, in all directions. You need some way to represent where you are and what kind of regions, sections, and chunks you've got. This is actually the map that I created during lockdown. And there's this cool tool that lets you generate tiles, and you can actually zoom in and look around and on this map. So for example, in the map, they have this idea of sections, a chunk made up of 16 sections, and each section has 16 by 16 by 16 blocks, and sort of broken down like that. And then, for example, I've highlighted here 3 by 3 chunks would contain 500,000 blocks if they were all filled up. But that's only a 50 by 50 meter area in the game. So, the draw distance normally is sort of 20 chunks. So you can imagine there's a lot of data that's got to go back and forth when you're walking around. So they've done quite a lot of optimizations to make sure that when you're looking in a certain direction, you're only getting data from that, what you would be looking at. So I'll give you a little bit demo of this microcontroller that we've got. It's going to work. So I've got a camera set up over here, and that's looking at the BlipBoy. Oh no, I've missed the focus. BlipBoy over here, and I've also got Minecraft ready to go. Let's see if this works. Hey, so you can see in the background, I've just got the terminal there, just so you can see all that wall of text was that initial data chunk to represent one of these sections. So I've got this world in which is just one of these sections, one of these chunks in this big section here. I can turn on some extra debug information. You can see there's this big column of big column is a chunk, and each sort of section in this chunk. And I've only transmitted one of these, but it was enough for more than enough for my little microcontroller, and it's going over a serial port to my computer. And so all the serial port's doing is just if it gets some data on the socket, gives it to the serial port, and then when it gets some data from the serial port, it gives it to the socket. So it's just kind of a bridge because my microcontroller didn't have an Ethernet interface. So I also loaded in some switches, and then you can click the switches, and then the LEDs are toggling on and off on the microcontroller. And this was similar to the demo that guy had created on his world's smallest Minecraft server. And I really love this because it's so practical, and it gives you this virtual world inside your microcontroller, which is this tiny little computer running just over there. But now I can kind of see a representation of it. All this data is stored on that little microcontroller, and I'm just sending it, commands that happen to be visually represented like this. I think this has this awesome potential to, give you a better way to debug microcontrollers, for example, where normally you're looking at just logs, whereas if you can just visualize it, it might make it a lot easier to see what's going on. So I'm glad that worked. Let me just disconnect from this. Oh no, I broke a block. That's fine. It'll come back when I come back. Let's disconnect before I do any more damage. Let's switch back to slides. So interesting thing I wanted to highlight was the way that it figures out what blocks go where. It just has this unique ID for each block. And so those levers, there was an ID for on the floor, facing north, powered on, true. And there's a separate ID for face on the floor, facing north, powered on, false. And really, in my code, all I have to do is just send an update block and then give it the ID that the block's changed to. And then the client renders that as a block in that position on or off. So the server has a really minimal job. It's just saying, hey, block's changed. It could have been a dirt block changed. It could have been a lever being toggled. I think that is referring to the great flattening in the Minecraft protocol that I've seen it mentioned around the place, where people got annoyed and had to rewrite their clients and servers. but it does make it super easy to work with. So what about monitoring? I came across this blog post, and Minecraft as a Kubernetes admin tool. I just love this too, because they'd represented their pods as animals in the game. And so that you could presumably spin this up, connect to your Kubernetes cluster, and then see all of the different containers running. And then you could even go along and see the names. And if you kill the chicken, for example, it'll kill the pod in your container in your cluster. I just thought that was fantastic. I don't know enough about Kubernetes to start that up myself, although I think it's fairly straightforward. It uses a different version of Minecraft as well. So I've got, I'm on the Java edition, but so I looked around and found Dockercraft, similar kind of thing. And I love this warning that was on the GitHub README. It says, warning, please use Dockercraft on your local machine only. It currently doesn't support authentication, and every player should be considered a root user. That's perfect. That's exactly the kind of thing I want to try out. So I'll just see if that demo is going to work. And just have to bear with me as I need to launch an older version of the game. This is what I was saying about some games. Some projects are working on older versions. So this here is a representation of the containers running on my computer right now. So you can see Dockercraft. That's the Docker container that runs this whole thing. You can also see it's updating CPU usage, memory usage, and you can come in here. You can start and stop it, and you can delete it as well. I won't touch this one because otherwise it'll kill the demo. This one, so the orange ones are stopped. I don't know. It just doesn't look very important. So you can just go and delete your image. Yeah, so it's kind of fun. I have this long train of containers spawning off into the distance, and I wanted to see what was going to happen if I remove all of them at once. So I got a WordPress. WordPress is running here. You could stop it, and so now that container stopped. Or you could start again. I think you could even run commands from the command line. So, I mean, I don't know how practical it is at this configuration, but it's still quite fun and amusing. I think you could do a lot more to maybe just make it of your project, and then you could see how things are doing, and you could update blocks in a different way. I was going to have a quick look if I could delete all of them, and I've just, for the life of me, forgotten the Docker. I'm not sure I know the command to delete them all. There's a command. It was up before I had it. It doesn't matter. We'll move on to the next one. So that's sort of monitoring your system, although in quite a crude way. What about monitoring an application? So I wanted to build a web server and then really visualize what's going on in the application itself. So I want to visualize HTTP requests in the game, visualize the users and see what state, the users of my website are, are they authenticated and things like that. Maybe there's some timed out requests or something I could identify and go and fix those. And in creating this, I came up with this hypertext Minecraft language, which will make sense in a moment. So the architecture of this project is you have your browser, and what I really want is the browser to make a web request, and then something in the middle to translate that to the Minecraft server. And the Minecraft server is going to be doing all the heavy work, actually implementing the web server itself. And then this sort of Minecraft client is going to be the one that takes the request and converts that to the correct, Minecraft protocol commands. And so the server and the Minecraft client will have a good chat backwards and forwards, and then the Minecraft client can return the result. And there's this Prismarine.js project, which has a fantastic set of tools. There's some bot clients, there's some server clients, really awesome. So I got my debug client would then connect into the Minecraft server there. Well, there's a big problem with this architecture, is this bit in the middle. As I implemented it, I needed to make a single process per request because the client didn't handle multiple requests at the same time very well. And the first iteration of this talk, the audience actually crashed my demo, which was not ideal. So I've improved it now, hopefully. And it also makes 200 megabytes per request. So that's ridiculous in itself. 10 to 20 seconds per request, because there's a lot going on to serve your request. And for example, 100 requests at the same time, that's 20 gigabytes of memory. And so a number of times over the last few weeks, my computer is just entirely ground to a halt because it just has no more memory. Everything's out just because I've spawned hundreds and hundreds of little Minecraft clients, each one downloading a copy of the world. You'll see what you'll see in a minute. So my solution to fix this is I think I may have found the perfect application for serverless AWS Lambdas. I'm going to put this API gateway in the middle. So our browser is now going to send the request to the gateway. The gateway can then spin up as many Lambdas as we want. And each of those Lambdas has a Minecraft client on it, connects to the Minecraft server. And then we can still have our little debug connection to there. So instead of a process per request, now we've got a Lambda function per request. 3 gigabytes of RAM available for each request. Fantastic. 30-second timeout. I think you could extend this if you change things up a bit. So I can do 1,000 concurrent requests. I didn't get that many before my server crashed, but it looks better than before. So let's give you a quick demo of that. So just give me a second to switch out of this. Oh, geez. Okay. So this is the world that we've got. It's a bit crude because I'm still a beginner in Minecraft. I've just taken over a village here. We've got sort of the walled area, which is the authenticated area of my web server. And we have outside the walls, which is some resources that are unauthenticated. So you can see here, they've got this signpost here, which is going to be our home. And we've got a book and quill. So if we have a quick look at what that does, here's my hypertext markup language, hypertext Minecraft. So let's see if we can get a request to come in. I'm just going to use curl just as a simple example. Let's see if I can grab this. Hey, so we have a request come in, spawned in, and we're currently wandering on over to that box, have a look and see what's inside it. And there you go. There's the in a ridiculous fashion, the HTML is printed out here as the request. So we can also do that in a web browser. It gets a bit more exciting. A second. Okay, so we'll make this request. So you notice a new player's joined the game. He's coming on down. And there's the HTML rendered in a browser. So let's see what happens if we go log in. So here he comes. Go into the house. So there's another box up here. And yes, we have returned a form with a single button. Only the best HTML. And so there you go. About as good as I can get with redstone contraptions. So you push the button, and so in the game it's now open to trapdoor. Now we're inside this walled area. So a couple things we can do. We can farm or fight. Let's have a look. Farm. So yeah, got some carrots. There's a couple of different things we can do here. Let's go back and let's go fight. So it goes over, finds the nearest iron golem, tries to have a go at it, but it gets killed. And you can see the result was now the request was slain. So now if we redo again, we're actually, because we died, we're going to go back into respawn. And even though we're trying to access it, so I just refreshed that page, we're trying to access that authenticated resource, which was fight. But because we're outside the walled area, we can't get in. So it's the pathfinding algorithm is looking for a way, but it can't get there. So this request is now pretty stuck. You can see the browser is still waiting for a response, but we can speed that along. So there we go. Yeah, that's the insanity of a web server implemented in Minecraft. Now, if you guys want to have a go, I don't know if anyone's willing to. Actually, webcraft or not.io.lol. There we go. We've got a couple coming in. So last time when I did this, we had a whole bunch of people join in quite early. I didn't get to show off the majority of the demo before we crashed because we just used up too much RAM. But now, because there's actually a Lambda instance spawning per request that's coming through, they're all individually connecting to the Minecraft server, and it's just vanilla Minecraft server, and then making that request. Oh, yep. So you guys, some of you are off into there. Let me. I need to fix this. Seem to have lost my thing. There we go. So you're probably making in there. I wonder if anyone's getting to fight the golem yet. I quite like this. I mean, it's a bit silly, but it is also quite interesting that you could see this visualizing your logs, for example, rather than actually implementing the game inside Minecraft in this way. But yeah, it'd be cool to see your requests going through, be able to interact with them. Let's see if we can help some of these people. Yeah, well, I could play this for hours, so we'll go on to the next bit. You guys can keep going in the background. Yeah, so that's our webcraft.lol. I'll try and keep it up over the next wee while. I don't know how I'm going to have to implement the server or something. I'll figure it out. If it's not working, just try again later on. So what are conclusions? Well, hacking in Minecraft actually is a really good match. And no matter what your skill level is, there's actually something there for everyone, I feel. So if you're just starting out getting into this kind of thing, because there's such a huge community and all these projects already existing, it's quite easy to pick something up and have a look. But you can also go to the extreme and spend thousands and thousands of hours and implement this crazy project. Yeah, there's something there. I also like the client-server implementation that they have. So it's really interesting to learn about that. Even if you're just making a single-player game, it can help separate those two out and let you do things like, swap out your front end for a ridiculous front end, like a web server. So that's me.
Well, thank you so much for that, Jeremy. The chat has gone absolutely wild. We unfortunately have run short on time, so we're not going to have time for questions. But hopefully you'll be. You mentioned being around in the Discord for a little, and there were questions. So
cool.
Yeah, and that was great. We mentioned like the murdering a chicken for the. For the demo gods to work out so well in your favor was
you got no idea the setup on this side of the screen. It's quite involved. I'm just
I can imagine. I can absolutely imagine. Well, thank you very much, and have a great evening.